Hello students, welcome back to lecture series on EM3 subject. Already we have uploaded plenty of the videos in our channel. So if you are interested to see this video, go and check in my playlist. So in my today's video, I'm going to explain to you all some of the example, very much important example in the perspective of SPPU exam, based on the method of variation of a parameter for finding the complete or general solution, or you can use it for the finding particular integral only. Okay, yes, let's get dive into our today's lecture. First of all, we're gonna see as the method it is here, then at the end we go for solving the examples. Okay, now see here, so we have the example d square y by dx square minus 6dy by dx plus 9y e raised to 3x by x square. So we have to solve complete solution using variation of a parameter. Now always remember that whenever we want the variation of a parameter, first of all we have to find out the complementary function. Okay, so let's proceed for the complementary function here now. Okay, for the complementary function, okay, first of all we write auxiliary equation. Okay, auxiliary equation we are going to write first of all auxiliary equation. Okay, so write down the auxiliary equation by using this d square minus 6d plus 9 which is equal to 0. Okay, d square minus 6d plus 9 which is equal to 0. This one is our required auxiliary equation. Go for finding the roots of this auxiliary equation. Okay, that means we want the two numbers, their multiplication 9 and their addition it is minus 6. Okay, so we take 3 and 3 3s are 9 and their addition we want minus 6, so we consider minus 3. Okay, these are the two numbers, so minus 3 into minus 3 which is a plus 9 and minus 3 plus minus 3 which is minus 6. Okay, I'm going to expand here d square minus 3d plus 9 which is equal to 0. Okay, I want the root of this auxiliary equation. Now take d common here, d minus 3 plus again take 3 common here, minus 3 common here. Okay, minus 3 under bracket d minus 3 which is equal to 0. So we got the d minus 3 which is equal to 0, then d which is equal to 3 which are real. Okay, which are the real and repeated root we have present here. Okay, yes, so we are going to write its solution as, okay, so we are going to write complementary functions c1x plus c2 e to the power 3x. Okay, e to the power mx. Okay, but you are asking me that for finding particular integral we need c1 y1 plus c2 y2, but here we don't have y1 y2. Okay, so we have y1 y2, we have to find out using this one. Okay, so complementary function we are going to write c1 e to the power 3x into x plus c2 e to the power 3x. Okay, now see that I got the y1 this one, y2 this one. Okay, so I'm going to compare complementary function cf as a c1 y1 plus c2 y2. Okay, c1 y1 plus c2 y2 here. Now the value for y1 e to the power 3x into x and the value for y2 e to the power 3x here. Okay, so I got the value for y1 and y2 over here. Okay, using the value for y1 and y2, let's go for finding the particular integral. Okay, so as we know that particular integral can be written as u into y1 plus v into y2. Okay, yes, we have to find out u and v over here. Okay, so for finding u and v we need a Wronskian w. Okay, we need a Wronskian, okay, w which is a Wronskian here. Okay, for this Wronskian we go for finding w. Okay, so we take y1 here, y2 here. Okay, okay, y1 y2 here, again y1 dash y2 dash over here. Okay, okay, so put the value of y1 e raised to 3x into x and y2 e raised to 3x. Okay, y1 dash, differentiate this one. Now we can see here e raised to 3x into x, this is the function u into v. Okay, so you have to apply rules for different product rule for differentiation here. Okay, in order to find out the e raised to 3x into x differentiation. Okay, and e raised to 3x has differentiation 3 e raised to 3x. Okay, let me write this one, d by dx of u into v. Okay, that means first function as it is d by dx of v plus second function as it is d by dx of u. Okay, this one is a by part rule for rule, okay, or product rule for differentiation. Apply this rule as it is over here. Okay, that means e raised to 3x as it is, differentiation of x, it become x plus x as it is, e raised to 3x differentiation 3 e raised to 3x. Okay, okay, this one is our determinant. Okay, so we have to solve this determinant further. Okay, 3x into x, e raised to 3x into x, this into this. Okay, that means 3 it is here, e raised to 3x into e raised to 3x. When we are base same, we add their power, that means that gives e raised to 6x. Okay, into x. So this multiply these two bracket, these two terms, you will get this one. Okay, yes, again minus, multiply these two terms, e raised to 3x into e raised to 3x, base same, add their power, that means e raised to 6x. Okay, again e raised to 3x into x, 3x plus 3x keep as it is, e raised to 5x into e raised to 3x. Okay, sorry, it is 3x here. Okay, e raised to 6x, it goes to that. Okay, this one is our term. Okay, yes, we got this term over here. After multiplication of these two, multiply negative sign under bracket and take this with this one. Okay, 3 e raised to 3x, 3x e raised to 3x. Okay, minus 3x e raised to 6x, 3x e raised to 6x minus e raised to 6x. Okay, I taken these two terms together. Okay, and multiplied negative under bracket here. So 3x e raised to 3x, take 3x common. Okay, take 3x common, then go for finding their subtraction. So here we got the 3x e raised to 6x here, so negative 3x e raised to 6x here and e raised to 6x here. Okay, negative this one. So this positive, this negative term get cancelled, we get the Wronskian minus e raised to 6x here. Okay, this one is our required Wronskian, so which is helpful here for finding the further solution of our particular integral. Okay, yes, I got the Wronskian here. So u into y1 plus v into y2, y1 y2 we know that, but we have to find out the u and v over here. Okay, so value for u, okay, so value for u, it can be written as integration of minus y2 into x divided by w dx. Okay, so we have all these values here, replace it here, then integration of minus y2. Okay, so minus of y2, y2 means you can see that y2 is e raised to 3x. Okay, put this here, integration of e raised to 3x. Okay, so y2 e raised to 3x minus y2 into x. What is the value for x? X here, e raised to 3x by x square. Okay, this one is our x here, which is the right hand side, e raised to 3x by x square. Replace here into e raised to 3x by x square, total divided by, we have here w, Wronskian as a minus e raised to 6x. Okay, this one is a Wronskian, I replace here dx. Yes, so what we do, we go for solving this step further. Okay, yes, so minus of e raised to 3x into e raised to 3x. Okay, so what is the, how can we write next step? Minus out here, e raised to 3x, e raised to 3x means e raised to 6x. Okay, e raised to 6x, total divided by x square and total divided by minus e raised to 6x. Okay, into dx. So we have to solve it further. Okay, we have to solve it further, then only we'll get the simplest form. So let's go for the simplest form. Okay, we can see that that negative sign, these are going to be a positive. You can see here minus minus upon this thing, minus x upon y, or x upon minus y, or minus of x upon y, all these are equal. Okay, that means if negative sign for numerator, negative sign for denominator, or negative sign for entire term, these all steps are equal. Okay, so that means this negative gives us the positive value. So we write integration of e raised to 6x by x square, e raised to 6x by x square. Denominator of denominator always goes to the numerator, that means we write e raised to 6x here. Okay, dx. So we can see that how I have written Okay, denominator, sorry, it is a e raised to 1 upon e raised to cx. We write this one multiplied by this one. Okay, 1 upon e raised to cx. So take that denominator to the numerator. We write it as the integration of e raised to 6x multiplied by e raised to minus 6x divided by x square. Okay, so this one is the term of x square dx. So base same, add their power, e raised to 6x minus 6x, it goes to the 0. That means e raised to 0 is 1. Okay, that means 1 upon x square dx. This is the left term here. Okay, this one is the left term here. We have to find out the integration of 1 upon x square. Now I will explain to you all simplest way to find out the integration. So watch here carefully, guys. We want the integration over here. So for finding the integration, so if you don't know directly the integration, take x to the numerator, then we write x to the power minus 2 dx. Okay, so x to the power n, integration of x to the power n is x to the power n plus 1 upon n plus 1. Apply that result over here. Okay, then that means we get the x to the power minus 2 plus 1 upon minus 2 plus 1. Okay, that means x to the power minus 1 upon minus 1. Okay, then we write minus 1 upon x. This one is our required integration. Okay, for and the value for u. Okay, this one is the value for u here. So I got the value for u here. Let's work on the value for v. Okay, so I want the value for v. So the value for v, it can be we know that the value for v, which is the integration of y1 up into x divided by w dx. Okay, put all these values over here. Okay, the value for y1, what we have here, e raised to 3x into x. Okay, e raised to 3x into x into e raised to 3x by x square, integration of e raised to 3x by x square. This one is the value of x here, this one is the value of y1, and total divided by, we have Wronskian. What is the value for Wronskian we found, which is the minus e raised to 6x. Okay, minus e raised to 6x dx. So we have to evaluate this integration. Now see that it is not the complicated, it is one of the easy integration. Just convert it into the simplest form and then go for the integration. So then next step we write here. Okay, next step, e raised to minus sign, take it out here. Okay, e raised to 6x, it goes to the numerator, it becomes e raised to minus 6x. E raised to 3x into e raised to 3x means again e raised to 6x over here. Okay, x get cancelled with this x, then we left here denominator as a x only. Okay, dx. So e raised to minus 6x plus e raised to 6x, it gives us a value e to the power 0, which is a 1. Okay, so minus integration of 1 upon x dx. This is the left term here. Okay, yes, so 1 upon x, integration of 1 upon x, which is a log of x. Remember guys, this one. So minus of log of x, which is the value of v here. Okay, now see that I got the value for u, I got the value for v. Now let's go for finding the particular integral. Okay, particular integral can be written as u into y1 plus v into y2. Okay, so what is the value for u here? U here minus 1 upon x. Okay, value for u, which is a minus 1 upon x, replace here minus 1 upon x, the value for u. What is the value for y1? e raised to 3x into x. Okay, plus v. What is the value for v? Log minus of log of x. Okay, and value of y2, e raised to 3x. Okay, okay, these are the values here. Let's go for the simplest form. X get cancelled with this x, so minus e raised to 3x. Okay, minus e raised to 3x, that minus plus minus e raised to 3x log of x. Okay, yes, so what we do, take e raised to negative e raised to 3x out here. Okay, under bracket 1 plus log of x. Okay, this one is our required particular integral. Okay, so I got the required particular integral here, required particular integral over here. Okay, so I got the required particular integral as well as the complementary function here. Okay, complementary function. So we'll write complete solution. How we write the complete solution? Complete solution as complementary function plus particular integral. Okay, complementary function plus particular integral. Put the value of a complementary function over here. That means you have to replace this entire value as a complementary function, and particular integral replace it here. This one is our complete solution. Now see, this one is a very much important question from SPPU question paper. Okay, asked so many times in your previous year question. I hope you all have understood my entire solution over here. Okay, it's not a difficult, it is one of the easy solution. Okay, this one is the complete solution. You can refer it for your reference. Okay, so this one is the value for u and v. I hope you all have understood my today's lecture, which is one of the important question for your university perspective. Okay, even after, if you found anything difficult or if you have anything doubt query, let me know in my comment section. Okay, so I want you all to solve one more example for your homework. Okay, let me give one example for your homework here. This one is the example for your homework. I want you all to solve this example. It's compulsory for you all. Solve this example, comment me answer in my comment section. Even after, if you found anything difficult, let me know here in my comment section. Okay, this one is the example for your homework. Okay, so this is my today's entire lecture. I hope you all have understood everything over here. Okay, so even after, if you found anything difficult, confusing, or anything, okay, anything means anything, let me know in my comment section. So thank you everyone, thank you for my today's lecture.